Welcome to The Explainer. Today we are talking about one of the most clever tools in the software design playbook, the proxy pattern. Now, the idea itself is actually super simple. It's basically a smart stand-in for a more complex object. But you're about to see just how powerful it is for solving some really common and really annoying coding headaches. All right, let's just get right into it by talking about a problem that I swear every single one of us has felt. It's that moment of pure frustration when your beautiful application just stops. You know exactly what I'm talking about, right? Your app just completely freezes up. You've got that dreaded spinner going, and your user is sitting there getting more and more impatient. And it's all because it's trying to load some massive thing in the background, a thing you might not even need just yet. Now, this heavy object could be pretty much anything. Maybe it's a whole gallery of high-resolution images, or a really complicated database query, or even a connection to some remote service. The real kick in the teeth is that your application is paying that full performance price right up front, even if the user never actually clicks the button that needs that object. So, how in the world do we fix this? Well, before we even touch a line of code, let's think about a really fantastic real-world analogy that I'm willing to bet you have in your wallet right now. Just think about it for a second. Your credit card is a proxy, a placeholder for your actual bank account. It has the exact same main function, right? You use it to pay for stuff. But it's not the vault full of cash. It's a super lightweight object that controls and manages your access to the real, heavy, and secure thing behind it. And this little process perfectly nails the core idea of the proxy pattern. You, the client, you're just interacting with a simple, lightweight stand-in, the credit card. And that proxy handles all the complex behind-the-scenes communication with the real, heavyweight object, the bank, and it only does it when it's absolutely necessary. Okay, so let's bring this back to the technical side and see how we actually build this in our code. You know, the real magic behind this whole pattern comes down to one really simple but incredibly powerful concept: a shared interface. The big secret here is that they both speak the same language. See, both the proxy object and the real service object, they implement the exact same interface. And this is so important because it means your client code doesn't have to change one bit. It can talk to the proxy as if it were the real thing, which makes this pattern so clean to put into practice. So you've got these four players all working together perfectly. The client makes a request using that shared service interface, and it has no idea, and frankly, it doesn't care if it's talking to the lightweight proxy or the heavyweight real service. All that knows is, I'm asking for this, and the job is going to get done. You see, the proxy really acts like a gatekeeper. When a request comes in, it doesn't just blindly pass it along. No, it has the power to do other stuff first. It might be in charge of that lazy initialization we talked about, only loading the real service on the very first call. Or it might check a user's permissions, or even just log the request for analytics before finally sending it on. And that gatekeeper role is exactly what makes this pattern so incredibly flexible. Because depending on the specific job it needs to do, the proxy can put on a few different hats, or personas, to solve totally different kinds of problems. First up, we have our original problem solver, the procrastinator. The virtual proxy stands in for a really resource-intensive object. It gives you a lightweight holder and only creates the real heavy object when it's first requested. We call this lazy initialization, and it is a fantastic way to make your app start up way faster. Then you've got the bouncer. A protection proxy is all about security. It stands right in front of some sensitive object, and before it lets any requests through, it checks the client's credentials. Basically, if you're not on the list, you are not getting in. Simple as that. And finally, we have the local ambassador. A remote proxy represents an object that lives somewhere else entirely, maybe on another server across the world. It takes care of all the messy details of network communication, serializing data, handling network errors, so that your client code can talk to that remote object as if it were sitting right there in your own application. Of course, like any powerful tool in our toolbox, the proxy pattern is not a silver bullet. It absolutely comes with its own set of trade-offs that you've got to be aware of. It's incredibly powerful, but that power isn't exactly free. The real story here is about balancing trade-offs. On the plus side, you get an incredible amount of control. You can manage an object's whole life cycle, you can bolt on security, or even cache results if the real service goes down, all without the client having a clue. But there's a cost. You're introducing new classes, which adds some complexity to your code. And that extra layer can add a tiny bit of overhead, maybe slowing down responses just a little. And that quote really brings it all home. At its heart, the proxy pattern is about one thing: giving you a smart, manageable stand-in. It's an intermediary that becomes a control point, letting you manage complexity or access or heavy operations without having to disrupt the rest of your system. So the next time you're deep in your code, just ask yourself this: where could a smart stand-in make my life easier? Because whether you're dealing with slow objects, remote services, or tricky security checks, the proxy pattern might just be that elegant, simple solution you've been searching for.